Hello everyone and welcome back to the new fantastic tutorial about simulating your custom robotic arm in ROS Noetic. In our previous tutorials, we had created a simulation of our robotic arm using the ROS Noetic, the Move It Setup Assistant, the Gazebo and RViz. Now from these tutorials onward, we are going to try to play with that simulation. Like we are going to add some objects to the scene. We are trying to pick and place them using our robotic arm. So in our today's tutorial, we are going to learn how to add some objects in our RViz planning scene, because that is the first step that we need to do. Now today we are going to write a Python script which will add some objects in our RViz scene, and we will see also how to attach and detach them from our end effector. So first of all, you need to open the terminal and you need to go to your this workspace, your Catkin workspace. So type the command cd, the home symbol and your workspace name, and press enter. Then you need to go to the src folder of your workspace, and then you need to go to the move it manipulator package that we had created using move it setup assistant, and go to its scripts folder. Now we need to create a Python script to attach, detach and add objects in RViz. So type the command gedit, then give the name node underscore add underscore attach underscore detach underscore objects underscore in underscore RViz. Make sure you name the file like this, so that you will not miss any thing in future, because I will design the commands in our next tutorial based on these file names. Now press the enter button. So it will create a new blank Python file for you. Now I will not write the code step by step. Instead of, you can go to the link that I have provided in the video description and you will get to this GitHub page. So from here you can copy this Python file script using this copy raw file button, and then come to this blank Python file and paste the code here and save the code using this save button. So first of all, let's understand how this code works. First of all, we will add the Python 3 shebang here. Then here we will add some Python 2 or 3 compatibility. Then we will import some libraries. And again, this is for the Python 2 compatibility. And then again, we will import some messages and other important things. Then we will create our class similar to our regular scripts. Then in that class, we will initialize the move it commander object here. So you can use this link to know more about the move it commander. Then using our move it commander, we will initialize the robot commander object. Then we will initialize the planning scene interface object. Then we will get the our robotic arms planning group name and the grasping group name from this our constructor, and we will put them in the variable of the class like planning group and grasping group. Next, we initialize the move group commander object. So here we create a group object, and from move it commander we initialize the move group commander and we pass the robotic arms move group name. Then we get the parent frame link, the end effector link and the group names. And then here we define a blank variable box name which is empty, and then we print the information about the end effector link and everything on the terminal. Next, we have one function like wait for state to update. So basically this function is used to understand whether we have the object available in the planning scene or not. We are going to use this function to know if we have added our box correctly or removed or attached it correctly or not. So for this function, we have few arguments like the self, which is the default argument. Then we have the name of the box. Then box is known, which is by default false. Then box is attached, which is again by default false, and we give a timeout of 4 seconds, so which is used later in this code. Then here we define a box name variable which gets that name argument. Then scene object which gets the scene of this of the RViz. Then we start our get the start time when we started this function, and again we define the seconds in which again we note the time. Then we start a while loop. So here basically we are trying to see if our loop is not taking more than 4 seconds. And then here we have the we define a variable attached object. So in that we get the all the attached object available in the scene with the name of our box. Then we check if the returned list is have some elements in it, and again we get see if the box name is known to the scene. So here is a note, like if the box is attached to the robotic arms end effector, then this box will not be known to this what I can say to this scene. So this is a good way to understand if the object is attached to this your robotic end effector or not. So then here we have the loop, like we check if the box is attached is equal to is attached. So which is, if you see here, box is attached is here. So if we pass here true, so this should be a match with this is attached. So this will be checked, and then we have this like box is known, again this is passed here. So if the box is known is equal to this is known, so when this full condition gets fulfilled, it will return true value, and then it will stop for 1 second, and again it will get the seconds the value of this time here. So what happens is, suppose if this code block is not getting executed, it will come here, it will wait for 1 second, it will again record the time, and if this loop has taken more than 4 seconds, so as you can see when it comes here, this loop will get terminated, and we will not get any result as output. And otherwise, if this condition gets fulfilled, we will get true as a return. So this is to check whether our box is attached or detached or removed from the scene. Next, we have the function def add box, which is the first one we need to execute. So in the add box function, we have the name of the box as an input. Then we have the X, Y, and Z coordinates of that box where we want to spawn the box. Then we have the sizes of the box in the 3 direction like X, Y, and Z. And again, we have this timeout function. So in this add box function, first of all, we create this box name, which is the name of the box, which we take from the input. Then again, we take the input, the scene planning scene interface of our class, which we had created here, if you see. Then here we create a box pose whose type is geometry msgs.msg.pose stamped. Now to this box pose, we set the header, which is the frame ID, which will be the world. Next, we will set the X, Y, Z and the orientation values, roll, pitch, yaw for our box. And then we execute the function scene, which is the planning scene interface dot add box, and we give our box name, the box position, and its size here. So if you want to know more about this function, you can use these two links available I have given in the script. So I will not explain it in a detail, but it takes 3 inputs, which is box name, its position, and its size. Next, we will update our box name of our class object with the box name that we have added right now in the scene. And then here we will call this function wait for state update. We will pass the name of our box, and we will pass the box is known is equal to true, because here we want that our object is not yet attached. So this box known should be true, and timeout will be equal to timeouts. So if this returns true, it means our box is attached successfully. So we'll return this. Next, we have this attach box function. So to this function, we give the name of our box as input, and timeout is equal to 4. Now in this function, we again create a box name variable in which we store our box name. Then we get the our robot commander interface object, which we have created here. You can see this robot commander object. Then we get the planning scene interface, which we have again created above, and we get the end effector link name. Then we get our grasping group name, which we have again defined above. And here we define a variable touch links is equal to from our robot commander interface, we get the link names of the group grasping group. So the whatever the group name we pass here, all the so this get links names function, it will return all the links available in that planning group. So for now here, the grasping group, we are going to set the planning group our end effector. So this touch links will contain the name of our end effector links. Next, we have this, we again print this touch links on our terminal, and then we execute the function scene.attach box. We pass the end effector link name, the box name, and the list which contains our end effector links, end effector links. Then again here we check the status of our box. For now, to this we pass our box name. Now, as we are going to attach the box to our robotic arm, this object will not be known to our planning scene. So we need that this box known should be false and the box is attachable should be true. So if this function returns true value, it means that our box is successfully attached to our robotic arm. Next, we have this detach box function. Similarly to the attach box, we take the box name, the scene name, and the end effector link name. And then we execute this function scene.remove attached object, and we just pass the name of our end effector link and the link of the object that we want to remove. And again, I have given the links to API references for this function. And again, we check for the state of our box. And now again, we pass the name, and the box is known should be true, because detaching the box from the robotic arm makes the box known to this scene. And box is attached should be false. Now again, we have this remove box function which will completely remove that box from our scene. So here again we get the box name, the scene, and from that scene we remove this box name. And again we wait for the state for updated. So here the box is known should be false and the box is attached should be false. And we have the class destructor which will delete our class once we delete the object. Next, we have our main function. In this main function, we initialize our node, which is the add, attach, detach object in RViz. Next, we create the robot arm object, which we create from myRobot class, and we pass the first argument as the uh, planning group name of our robotic arm, and the second argument as the planning group name of our end effector. So in my case, they were arm group for robotic arm and hand for end effector. Then we run a for loop, which is executed till the ROS is not shut down. And here we define a variable task and we get an input from the user, like enter add to add object, attach to attach object, detach to detach object, and remove to remove the object. And here basically we have the looping, like if the task is add, we call the function robotarm.add box, and we give the box name as package $1. Then we give the position, which is 0.00, 0.6059, and 0.0510, and the size is 0.3 by 0.3 by 0.3 meters. And here in response, this add box function will return the value. If returns true, then the box will be attached. So here we check if the response is true, we will print on the terminal like added the object. Similarly, we will call the other functions like the attach, detach, remove. And then if we have one condition here, if the user types X, then it will break the loop and then it will quit the code. And at the end, it will delete the robot arm object. Now let's save this script and close the file. Now in this terminal, before we run our simulation, make sure you make this newly created file executable. So type the command sudo chmod +x and type the file name that we had recently created and press enter. It will ask you for your Linux password. So enter your password and press enter. So once you execute this command, type ls, and in the output you should see the file name that we created recently in a green color, which means it is now executable. Now clear the terminal, go to your home directory and start the ROS master using the command ROS core and press enter. Now create a new window. Now go to your Catkin workspace and press enter. Now run the setup.bash file and press enter. Now launch our robotic arm simulation. So we needed to type the command ROS launch, your MoveIt manipulator package name that we had created using MoveIt setup assistant, and then the launch file, which is this full robot arm simulation.launch, which we had created in our previous tutorials, and press enter. So this will open the simulation in RViz and Gazebo. So now let's arrange the windows side by side so that we can see everything at a single time. So now, so now you can see both my windows like the RViz, the terminal and the gazebo. Now in the terminal, open a new window. Make sure you are in your Catkin workspace. Again, run the source file, that is setup.bash, and press enter. Now to run the Python file that we had created, type the command ROS run your move it manipulator package name and the file name, that is the node underscore add attach detach objects in rviz.py, and press enter. Once the file starts executing, or once the file gets executed, it will print here all the information like the world, the end effector link, the group names, and then it will ask you to enter the command like enter add to add object, attach to attach object, detach to detach object. Now when you click add, it will add one object in your RViz planning scene. So you can see here we have added one small cube. If you go here in RViz in the planning scene objects, here you can see this package $1 is added. So you can see here we have this object available here. So basically I have added it at the location from where our robotic arm can pick this box. But if you want to modify this position, you can open this Python script, and here you will find the function call on line number 189, where we have given this arguments like the name of the box, which is package $1, its position and its size. So you can modify this to change your box position in the RViz planning scene. But now here you can see the object is only added in the RViz planning scene, and it is not added in the gazebo planning scene, because the RViz planning scene is completely different from the gazebo scene. So to learn how to add the objects in the gazebo planning scene, we will see that in our next tutorial. So in this tutorial, we are going to see the RViz planning scene only. So now we have added this object in our RViz planning scene. Again, our script is ready to take our next command. So before that, what we will do is we will select in the planning tab of our RViz, we will select the planning group as hand, and we will open our end effector, and we will click on plan and execute. Now our end effector is opened. Now again, I will select this arm group, and then I will give the command to go to this pick object position, and then I will click on plan and execute. So it may take some time to plan the position. So but as you can see, there are some issues to go to this position because it is interfacing with our robot's position. So we will take it little to this side, and then we will click on plan and execute. Now you can see the robotic arm has moved to this position, and now in this terminal we will give the command attach, and as you can see, as soon as we clicked enter, it printed like the touch link names, which are the links of our hand group, and it said attach the object, and the object you can see is now turned to the orange color. Now if I try to take my arm to the 0 position and click on plan and execute, you can see the box is lifted with our robotic arm in RViz. Now we will again go to the pick object position from where we lifted our object, and we will click on plan and execute. So it will again go to that position. Now our script is again available to take the functions or the commands. Type the command detach and press enter. Now you can see again the box is turned into the green color, which means the box is now free. And now to remove the object from the planning scene, we will type the command remove and press enter, and you can see the box is now removed from the planning scene. And to exit from the script, you can type X and then press enter, and the script will stop working. So in this way we have learned how to add, attach and detach the objects in our RViz planning scene interface using a Python script. Thank you so much for watching this tutorial. See you in the next tutorial where we will learn how to add similar object in our gazebo planning scene. Thank you so much for watching. Please do not forget to hit the like button if you like this video. Please do not forget to subscribe my channel if you haven't subscribed it. Thank you so much.